Hi guys, so in this video we will be looking at the answers to the questions relating to topic 3.2 ionization energy. The first question is define first ionization energy. Now first ionization energy we define as the energy needed per mole. What is a mole? It's a certain number of particles, 6.02 times 10 to the 23rd number of particles per mole to remove the first electrons from atoms in the gas phase. I want to move my face. Okay. Our second question says explain why the first ionization energy of 2.2.1 magnesium is greater than that of sodium. Now guys, when you discuss this, you always need to look where these elements are with in comparison to one another on the periodic table. Now sodium is in group 1 and magnesium is next to it in group 2. So we need to compare an element in group 1 with an element in group 2, and both of them are in the third period of the periodic table. So what does it mean if they are in the same period of the periodic table? That we need to ask with one another. And what does it mean if they are in different groups? Okay, so they make it clear that magnesium has a greater first ionization energy than that of sodium. Now what can that be? Okay, so the reason will be both magnesium and sodium are in period 3. Thus, they have electrons up to the third energy level and the same amount of electron shielding. What's the difference? The nuclear charge of magnesium is greater, thus exerting a stronger attractive force on the electrons, on the valence electrons specifically. What does this mean? More energy is needed to remove an electron from magnesium. Okay, so guys, you will see that I've written down this answer very complete. And this is what we expect from you in a test or exam, is that your answers will be written down as complete as these ones are here. Okay, so you have to identify what are the same. They're in the same period. What does it mean if they're on the same period? They've got electrons up to the same energy level. What does it mean more? It means that they've got the same amount of electron shielding. What is the difference then? Magnesium has a greater nuclear charge, therefore it will exert a greater attractive force on the valence electrons, and more energy will be needed to remove that electron from an atom of magnesium. So there's 6 points that you need to address for a complete answer that is correct in this sense. So please work through this meticulously to make sure that you have all the points. Now, our next question asks us to explain why the first ionization energy of calcium is less than that of beryllium. Now, to answer this question, guys, once again, we have to go through the same process, asking ourselves, what is the same, what is different? Okay, now looking at what it is the same, if we look at calcium and beryllium, and we go to group 2 of the periodic table, we find beryllium in period 2, and then we find calcium in period 4. Okay, so they're in the same period, but they're in the same group, but in different periods. So in other words, this tells me something. They've got the same number of valence electrons. But as I move down in a group and I go to next period, what does it mean? I've got more energy levels. What does more energy levels mean? It means there's more electrons in between that can limit the attractive force of the nucleus on the outer electrons, the valence electrons. And we call that effect electron shielding. Okay, so here we will say, so both calcium and beryllium is in group 2. Calcium is in period 4 and beryllium period 2. Calcium have electrons in higher energy levels, thus more electron shielding. This weakens the attractive force of the nucleus on the valence electrons, thus less energy is needed to remove an electron from calcium. Okay, so if we run through this answer, both of them are in the same group. Calcium is in period 4, beryllium in period 2. Calcium does have electrons in higher energy levels. Thus, more electron shielding will happen. What does this do? It weakens the attractive force of the nucleus on the valence electrons. Now I need less energy to remove the electron from calcium. 6 points once again. If we go to question 2.2.3, it says explain why the group 18 elements has the first ionization energy that is the greatest in a period. Okay, so what do we know about in a period? In a period, the valence electrons are in the same energy level. Thus, the same amount of electron shielding. Okay, but what changes? Group 18 elements have the highest nuclear charge in the period exerting the greatest attractive force on the valence electrons, thus the most energy is required. Okay, so to run through this answer, in a period the valence electrons are on the same energy level, the same amount of electron shielding. The group 18 elements will have the greatest nuclear charge of all the elements in the same period. This means it will exert the greatest attractive force on the valence electrons. Thus, the most energy will be required to remove the electrons from the group 18 elements. So here we've got 5 points that we have to mention so that our discussion is complete. Our final question asks, how do the first ionization energies, there's an S missing, of metals compare with that of non-metals in general? Explain the difference. Okay, now guys, if you go and look at the trends, what do you see? What do you see? How does the values compare of metals with non-metals? Okay, so let's first mention that. So the first ionization energies of metals are lower than that of non-metals. Now, why is this so? Metals form positive ions as they lose electrons to gain an empty outer shell. Non-metals gain electrons to form negative ions. It requires more energy to remove electrons from non-metals as they have greater nuclear charge with the same amount of electron shielding when comparing metals and non-metals in the same period. Okay, so let's just quickly discuss this answer. It just means that in general, the metals have lower ionization energies than that of the non-metals. Why? Because the non-metals tend to form negative ions. Why do they form negative ions? Because they've got greater nuclear charge. They've got the same amount of electron shielding if you compare non-metals and metals in the same period of the periodic table.